So the prerequisites, as they were already mentioned on the website, you should know all the data structures, how a tree works, what is a graph, what is a hash table, what is a heap. In this class, we will quickly brush you up with the concepts of data structures using the C++ standard template library, in which all the inbuilt data structures are there. And Deepak Bhaiya will take you through the journey of STL. But before that, we have a small warm up with the mathematics part, which I will be taking up. This is a advanced course. Ashish. Suyesh is asking me what all topics are helpful for first round of ICPC. See Suyesh, in the ICPC first round, there are questions from dynamic programming, which is an important topic. There will be questions from graphs. There could then questions from mathematics and some ad hoc problems, right? Ad hoc problems are also there. Implementation based problems are also there from topics like arrays and strings. You will find questions. So these are the most important topics for the first round of ICPC, right? It is coming up next month. So these are the important topics, and we will try to cover these topics before November first week, right? So for a warm up, I am discussing one problem. So the problem is the birthday paradox problem. Quite possible some of you have already solved this problem, but maybe not a lot of you. So let me discuss what is this problem, right? So what this question is saying, yeah, Nikhil, I know 5th November you have an online round for ICBC. We will make sure that the topics I have told will be covered till November 5. Right. So the first problem is the birthday paradox problem. So what the question is saying, what is the minimum number of people that you should have in a room such that the probability of having two people same birthday is 50%. What is the minimum number of people in a room such that the probability of two people having birthday on the same day? We are talking about the date. Let's say the date 15th October. It is 15th October दोनों का बर्थडे है. So what is the probability? What is the number of people such that the probability they have same birthday is 50%? So any ideas, any guesses how we can approach this question? Let me simplify the question first. So instead of 50%, let's say what is the number of people you need to have such that the probability is 100%. I can say with 100% surety that two people are having same birthday, then there must be n people in the room. What is the value of n? Yeah. So I got the correct answer from Ayush, Shivam, Rohit, Tushar, Yash. Everyone is giving me the correct answer. We are assuming if it is not a leap year. If it is not a leap year, then a normal year has 365 days. And I know if I have 366 people in the room, then the probability of having two people same birthday will be 100%. So 366 is the correct answer. So the correct answer is 366. Right. So Ayush has given me then another answer which is correct, but for not for this question. It is correct for 50% probability. All right. So any guesses for this question? What is the number of people for having 50% probability? Any guesses? Nikhil is asking what is the concept applied. Nikhil, see, it is very simple. You can say it is kind of pigeonhole principle. If you have suppose 366 people and you want to assign them birthdays, you can have only 365 unique values. So the last person will have a birthday which will match with one of the persons. Yeah, so lot of students have given me the correct answer, which is 23. All right. So I think you have solved this question pretty quickly. So it was an easy question. All right. But we will see how this is being solved. Might be you have solved it earlier. We will also give you some bouncers in the course such that you take more time to solve, right? No, this is not a pigeonhole principle right now. We will come to pigeonhole principle later also. So see what happens is, let me start with a very simple explanation of this question. So let me say if there is one person in the room. Let's start with the smallest value, two persons in the room. There is a room and there are two persons in it. So what is the probability that they have a different birthday? They have a, let's say, same birthday. Probability of two people having same birthday will be, what will be the probability? It will be 1 by 365, because out of 365 days I have to choose one. So it could be any one day. So two people having same birthday will be 1 365, 1 by 365. And what will be the probability of two people having different birthday? Different birthday. So if there are two people in the room, I want to make sure that both of they have a different birthday. So I can say it will be nothing but 1 minus 1 by 365, which comes out to be 364 upon 365. Now let's make this little more complex. Now instead of two people, there is one more person join the room, right? So what will happen? So see, when I say the first person, so first person was there, he can choose his birthday in 365 ways, right? He can choose any day for his birthday. So when there is one person, the answer is this. When there are two persons, the second person can choose out of 364 days, because one day has been chosen by the first person. This person can choose out of 364 days. So the probability will be 364 upon 365, which is same as this value which we have already computed. Let me add one more person to the room. Let's add one more person to the room. So now this person can choose his birthday in such a way that it does not clash with him hand in. Let's call this person as X, Y and Z. तो Z को एक ऐसा डे चूज करना है जिसमें X और Y का बर्थडे लाई ना कर रहा हो. So Z has only 363 options. So the probability will be 363 upon 365. And similarly for the fourth person, it will be 362 upon 365. And this will go on, right? So our question is saying we have to compute something like this: 365 into 364 into 363 up to n times. So we have to do it n times such that the probability of two people having same birthday is at least 50%. At least 0.5 चाहिए हमें, ठीक है? एटलीस्ट हमें 0.5 हमें प्रोबेबिलिटी चाहिए. एंड दिस थिंग वी आर डूइंग फॉर अ टू पीपल हैविंग अ डिफरेंट बर्थडे. तो ये हम जो रिजल्ट निकाल रहे हैं, दिस इज फॉर अ डिफरेंट बर्थडे. सेम बर्थडे के लिए क्या होगा? लेट्स से दिस इज p, दिस वैल्यू इज p, and for same birthday it will be 1 minus p. So I should make 1 minus p should be greater than equal to 0.5. It means p should be less than equal to 0.5. This is the result I have to derive. So I will do this thing n times such that this probability is less than equal to 0.5. Okay? Are you guys getting this? Yeah. So see guys, now this equation we can write it in the code. We can write the code for this equation, for this one, and we can compute the value of n. We can compute the value of n. So I am going to use the online editor by coding blocks. You can also try out this editor, a pretty cool ID. So what happens is there we have to compute the number of people such that the probability of having two people same birthday is 50%. So let me have one value called numerator, which is 365. Let me have another value which is of the type float. This is denominator. This is also 365 and float p, which is 1. So here p denotes the probability of some people having birthday on same date. Okay. So initially this probability is 1. We have already seen when there are two people, this value becomes 364 by 365. So this value becomes 19.997. It means I can say with 99.72% surety that two people will have the same birthday. When we have more people, let's say I have three people, so this value becomes into 363 upon 365, which is 99.17. It means I can say with 99.17% surety that three people will have a different birthday. So I can say while this probability is greater than 0.5, because हम 1 से start कर रहे हैं, we are starting from 1 and we are approaching towards 0.5. तो जब तक ये 0.5 से बड़ी नहीं हो जाती, तब तक हम जब तक 0.5 से छोटी नहीं हो जाती ये वैल्यू, बिकॉज वी आर स्टार्टिंग फ्रॉम 1 एंड वी आर अप्रोचिंग टुवर्ड्स 0.5. ठीक है. So I just need to, this while loop will stop when p becomes less than 0.5, because we are starting from 1. So here I can write uh, uh, let's say p equals to p into numerator divided by denominator, and in the next iteration numerator will be decremented by 1, and let me take 1n, where n denotes the number of people. So initially the n value of n is 0 and I will do n plus plus. So n denotes the number of people needed. ठीक है. So at every iteration I'm going to print, let's say cout probability is p and number of people are this much. And so we will see how the probability is going to decrease as the number of people are going to increase in the room. So you can see initially the probability is 1, then it becomes 99.72, then 99.17, जैसे हमने कैलकुलेटर पे कैलकुलेट की थी. Similarly, this probability is decreasing as the number of people are increasing in the room. So the probability is 0.49 and the number of people are 23. So this loop stops when p becomes less than zero point 0.5. So this probability point of 49 denotes that people have a different birthday, right? And so what is the probability for same birthday? So it is around 0.51. So it becomes greater than equal to zero point 0.5 when the number of people are 23. Yes, so 23 is the correct answer. So all those who gave 23 as the answer is correct. So did you guys get this thing? Why this condition is p greater than 0.5? Because while loop will stop when p becomes less than 0.5. That is the termination condition. So when as soon as p becomes less than 0.5, it means probability of people having different birthday is now less than 0.5. So probability of people having same birthday is now greater than 0.5. So can you tell me the answer for what is the number of people needed if we want to say with 90% surety that two people have the same birthday? What should I change here? What should I change here such that the probability of people I can say with 90% surety? I can say with 90% surety. What should be changed? Any ideas? So far Mohit has given me the correct answer, and yes, we will make it zero point 0.9. It will not. We will make it zero point 0.1. Sorry. So Mohit का answer ठीक नहीं था. All those who have written zero point 0.1 are correct because p denotes the probability of different birthday. So we have to tell for 1 minus p. So here it will be zero point 0.1. So let's run our code and see. Yeah. So we got the output. Yes. So the correct answer is number of people is 41. You can see here. So probability is this much. Probability of having different birthdays 0.09. So I can say probability of having same birthdays slightly greater than 90%. So probability has crossed 90% at this value. So number of people are 41. So it is quite interesting. If we have 41 people, we can with 90% surety that at least two of you have same birthday, right? With just 41 people. So is this question clear to you? Birthday paradox problem. You can also get the code. You can click the save button and this is the link. As soon as you click the save button, you get a URL which is the link for the code. I'm just texting you the code URL also. Saurabh is saying we need only 70 people to make it 99.9%. Yes, I think you are correct. Let's say if I do this, then the probability will become 99.9%. So you are close, Saurabh. Okay. Now you can change the values and you can try with different values also, right? So I hope you like this question. So this was a warm up. Now we are going to talk about some mathematical concepts. So whenever we say we are doing competitive programming maths, we see a couple of problems. So what are these types of problems we will see? Acha. Mohit, you are correct. Yeah. It is the equation when we do when we have a different birthday for every person, right? So for same, the answer is 1 minus p. Now I was talking about types of problems in mathematics. So a lot of types of problems are there. The most easy problems are the ad hoc problems or the formula based problems, and there are some problems which are the brute force problems as well. Okay, we will see one example here. And big integers is another kind of problem. Sometimes you get questions on ICPC, in ICPC code chef, that you want to compute some big factorial, right? This is another important category of problem, big integers. And exponentiation is one interesting category, which requires some good amount of practice. This topic we will do in the next class. So it covers the matrix exponentiation part, which helps us to solve linear recurrences, right? This we will discuss in the next webinar, how to solve a linear recurrence using matrix exponentiation, as well as we will cover a lot of problems from CodeChef and Spotch. Yeah. Then there are problems involving series, maybe sum of the series, maybe nth term of the series, AP है, GP है, HP है, ठीक है, उस type की कुछ problems. Then there is a very important and as well as interesting topic called pigeonhole principle. So this is a easy to understand topic, but sometimes the problems are relatively complex and you have to figure out how the pigeonhole principle is being applied. So in the first two lectures or in the first two webinars, I will talk about these topics. Some of these topics will be covered today. Some of these advanced topics will be covered in the next webinar. Inclusion exclusion principle again is an important topic which is based upon the set theory as well as the cardinality of sets. We want to find out how many number of elements are there which are divisible by 2 and 5, or maybe 3 and 4 and 7, or which have these many prime factors. So these kind of problems are part of inclusion exclusion principle. Then this is an interesting topic. One of the problem we have already solved right now, probability and expectation. I will try to come to expectation today itself if time persists. We'll discuss some problems based upon expectation as well. Then combinatorics, you already know, you have studied in class 11th and 12th, permutation and combinations, then rearrangements, those kind of stuff. Okay. So brute force, you have already tried a couple of problems. Brute force problems are like the complete search. So there is one problem, a famous problem on hacker blocks. So there is a game called German Lotto. We are going to see few examples of every kind of problem. So what the question says is, you are given some list of numbers. You have given a set of numbers from 1 to 49, and you are playing a game called Lotto. Lotto is a game. Okay? There is a game called Lotto, and you are given a set of numbers. So what happens is, out of these 49 numbers, you have to choose 6 numbers. So out of some 49 numbers, let's say there are some numbers 6, 8, 9, 10, 15, and so on. You have to play games, you have to choose 6 numbers such that these numbers are in ascending order. Okay? So choose 6 numbers. You have to always choose 6 numbers. Okay? There is a set of numbers and you have to choose 6 numbers such that all the numbers are in ascending order. So one of the answers could be, you have chosen these numbers: 1, 2, 6, 7, 8, 9. Another answer could be 1, 6, 7, 8, 10, 15. Right? So you have to tell me how many such games are possible. You have to print all such combinations, all such possibilities. So any approaches how you can do it? You can go through the problem statement again. Can go to the problem statement again. In this game, you are given numbers from the set 1 to 49, and you have to choose 6 numbers such that, Pranit says backtracking, Ayush says brute force, sort and select 6 slots. See guys, we are talking about brute force. So think of something simpler than backtracking and recursion. No, there cannot be any repetition. Mayank says, so Keshav is, I think, yeah, Yash is right. Nesting of loops. Rajat is also right. 6 loops with the first loop from 1 to 44. All right, all right. So, yes, it is a great answer by Yash and someone else also. So, this is the correct answer. So, good programmers are those who can think of more than 2 and 3 nested loops. In this problem, we are going to use 6 nested loops. Let's try to solve this problem. Alright. So brute force generally means you can do it using loops or recursion or backtracking, and you can explore all possibilities. Okay. So the first thing is, we have to sort the numbers which are already sorted because the numbers are from 1 to 49. Yeah, so we are going to code this now. See, we are as I write the code, you will get the logic also. It is a simpler question. So we are going to compute subsets of length 6, and we are going to pick numbers from the array in an ascending order. So see guys, let's say these are the numbers 1, 2, 3, 4, 5, 6, 7, 8. So you can pick first number from this. Next number can be any number from these numbers. Any number. Third number could be any number from the remaining numbers. Fourth number can be any number from the remaining numbers. Fifth number can be any number from the remaining, and similarly for the sixth number. So this we can do for all the elements of the array. Okay. So let's try to solve this problem. So suppose I have array I do not need because I know the numbers are from 1 to 49. Numbers are from 1 to 49, and we have to choose a subset of 6 numbers. Okay. So I can use one for loop for int I equal to 1, I less than equal to कहाँ तक जाएगा I? Let's say n is 49, range is 49. So I will go till n minus 5. Yeah, n minus 5 I plus plus sixth last number तक हम जा रहे हैं. ठीक है. I can choose the second number. J starts from I plus 1, and j goes till less than n minus 4, j plus plus, and again I can choose k. K starts from j plus 1, because we are going to talk about the remaining part. K goes till less than n minus 3 and k plus plus. Then we are going to talk about L. L starts from k plus 1, it goes till n minus 2. Sorry, L, it should be L, and L plus plus. Then for int m starts from L plus 1, m goes till less than n minus 1, and m plus plus, and the last loop for n. For int n starts from m plus 1, n is less than equal, n we cannot take, o ले लेते हैं, o less than n, o plus plus, and we can print these numbers. Cout I followed by some space or a comma, then j, followed by some comma, followed by k, followed by l. You could also have a array. Let's say instead of having this, I have a array. Let's int arrays something like this: 1, 3, 5, 2, 7. It should be a sorted array. If it is not sorted, then you have to sort it, and 12. Out of these arrays, I have two number of elements will be these: size of array divided by size of int. So out of this array, we have to pick a all sub-arrays, all subsequences of size 6, such that all the numbers of the subsequence are in the ascending order. So this is another way. I, j, k. So it will be now array of I followed by this thing. I, j, k, l, m, and o followed by and l. So let's try to run our code also. Return. So you can see these are the possible ways of playing the game, of making the subsets such that all the numbers are in the ascending order. So it is not necessary. Always need recursion or something like that. Brute force solutions can be written using loops, and it is not necessary that it will be only 3 loops or 4 loops. It can be 5, 6 loops in your question as well. Yeah, we are starting from index 0. All right, so yeah, this should be 0. Very good observation by uh, Rishabh. So yes, you got a more number of possibilities. 10 is chosen twice. Oh, it should be from m plus 1. There could be, there is a small mistake. Yeah, so we got lot of more answers. Yeah, I have corrected that. I have corrected the last loop. Yeah, there is a short delay. I get your responses a little late, but I have corrected this loop. So I think you guys got the question. Yash, uh, see guys, the complexity of backtracking is exponential. If you generate all subsequences, then it goes in the powers of 2, right? If you're doing something like, I want to compute all subsequences, suppose there are elements like a, b, c, d, e, f in this array, these are the elements. Then if you are going to use recursion, you are going to make two choices, if whether to include this one or not, whether to include this one or not, this one or not, this one or not. So it will be 2 raised to the power n, which is exponential. Okay, using recursion, if you are going to use recursion. But here we have simplified this. Let's say n is 10. So here the complexity of using these loops is, in each loop I'm iterating over the entire array. So it is n raised to the power 6, right? For but in recursion, you will also have to filter out. You have to select all those subsequences in which the length of the sequence is 6. All right. So that's why in the question n was given less than equal to 50, because n raised to the power 6 will work for only this constraint. But if you do 2 raised to the power 50, This will not work. This will take a lot of time. This will take a lot of time. So recursive solution will not work. The iterative version will work because the complexity is this, and for recursion, the complexity is this, 2 raised to the power n. What is the value of 2 raised to the power 50? I know 2 raised to the power 10 is around 1000. Sorry, 2 raised to the power 10 is around 1000, and I can say it is again raised to the power 5, so it is 10 to the power 15. This solution will not work. Your this method is work, and this is efficient because it is generating the desired output directly. See, recursion and backtracking both will be slow. Backtracking uh, is again a brute force, but this method is brute force, but it is much better than the brute force we expected, right? Even the bitwise operators uh, will take more time because you have to first figure out those numbers in which only 6 bits are set. That will take time. In finding the numbers, someone is talking about bit masking, again that is going to take time, because finding those numbers in which exactly 6 bits are set, plus uh, if you are using integers only have 32 bits, but in this question you have an array of size 50, right? You have to if you are planning to do bit mask, you will have to use long int. Okay, let's come to the next topic. I hope you got this question. This is one category of problems which involve brute force. The next interesting category is the category of big integers. There are a lot of questions on CodeChef regarding long factorials, long GCD. There are problems on Spoj also. So what happens is sometimes we are given some computations in which the number of digits in the answer can overflow the range of integers and long integers. It is quite possible that your answer is overflowing the range of long integer because it can store only at max 18 digits. Only 18 digits are possible. Suppose I want to compute 100 factorial. So 100 factorial has 158 digits or maybe zeros. I'm not sure. It has somewhere around 160 digits which cannot be stored in the long integer or in the integer, right? So what we do, we can use arrays in C++, and there is also a third party library called the Boost C++ library which can do the work for us, but we are not going to use this library. You have to set it up. So we are going to use arrays to compute a large factorial, right? We will see one example how to compute large factorial in C++. Fermat's little theorem we will discuss, don't worry. This will come in your third class, which is on number theory. There is also one tutorial of mine on YouTube on Fermat's little theorem. Yeah. So let's see how we can use arrays in C++ to compute a larger factorial. Let's see. Right. So idea is to use a array. The idea is to use a array in this question, because in array we can store as many digits we want. So you are given some number, let's say number is 1 2 3 4, and you want to multiply it by some number, let's say you want to multiply it by 15. So how do you do the multiplication? You do 15 into 4, 60, 6 carry. 15 into 3, 45, and 6, which is 51, 5 carry. 15 to the 30 and 5, 35, 3 carry. 15 ones are 15, and plus 3, 18. So you got 8, and 1 is the carry, which will be put here. Which will be put here. So what I am going to do, I am going to store these digits into my array. Suppose I am calculating something like 17 factorial. So I will multiply this number by 16. Again, 16 into 0, it will come here. Carry will be transferred to the next position, right? So what happens is, when we start multiplication, we take an initial carry of 0, and then we multiply it by the next number, right? So we can store the numbers in the array like this or like this. So what I'm going to do, I'm going to treat this index as the 0th index, first index, second index, third index, fourth index, and so on. Multiplication using arrays. Okay. So what I'm going to do, I'm going to maintain one array, and I'm going to maintain the output from the beginning, right? Here I have already written the indices. So you can treat, if the number is 1 2 3 4, it probably means the number is read this number as 4 3 2 1. This is 0th, first, second, and the third position, and I want to multiply it by some number, let's say 15. So 15 into 1, 5, and I will pass on the carry, which is 1. 15 to the 30, and so on, right? So we will use an array to multiply two numbers. Okay. So let's write one function. Write one function. Let me save the code as well. The ID of the code is 1743. So you can see in the URL, 1743 is the ID of our old code, and let me try out this problem. And I'm going to make one function called void big factorial, which computes the factorial of a number, and this could be a very large answer, right? So I'm assuming that answer contains at max 1000 digits. So I'm going to make one array storing the answer. So int star array equals to new int of 1000, and it is initialized by 0, and all positions are 0 initially, because answer is 0. Then I can say a of 0 is 1, because for factorial you need to start from 1. Okay. And I'm taking another variable n equal to 1, which denotes the index of the array I am working upon. I am uh, till which we have stored some digits. Okay. There is a array like this, in which all positions are 0 except for the first position, which is 1. And because I know factorial will start from 1, now what I'm going to do, I'm going to multiply it by 2. This will become 2. Then we are going to multiply it by 3. It becomes 6. Multiply by 4. This becomes 24. So what I do, I write 2 here and I propagate 4 to the next position. So now the value of n will become 2 because two positions have been occupied. So n denotes the index of the array before which we have stored some digits. So we have stored two digits, right? Before which, okay? And the logic of factorial is pretty simple. You have to multiply all numbers from 2 to less than equal to that number, and you do I plus plus. Okay? So for every number, you have to multiply a number A, multiply your array A, which has n elements in it, with a number called I. This function we are going to write. Okay? Void multiply, I'm going to write one function which takes the array, number of digits in the array, and let's take it by reference. You will come to know why we are doing so. So when I'm going to multiply, let's say the array is something like this: 1, 2, 3, and followed by some zeros, by some number, let's say 4. So initially the carry is going to be 0, carry value will be 0, which we have seen. उसके बाद हम सारे डिजिट्स पे आइटरेट करने वाले हैं. एन एन ने हमें बताया कि एरे में कितने डिजिट्स हैं, तो वी आर आइटरेटिंग ओवर द डिजिट्स ऑफ द एरे. ठीक है? ठीक. ठीक है, एंड 4 से मल्टीप्लाई करना है अगर, 4 1 जा 4, 4 2 जा 8, 4 3 जा 12. ठीक है, तो दिस विल बी द नंबर. करके देख लेना, 1 2 3 इंटू 4 करोगे तो 4 3 जा एक्चुअली वी आर स्टोरिंग इन द रिवर्स ऑर्डर. ठीक है, वी आर स्टोरिंग इन द रिवर्स ऑर्डर. So this number should be read as 3 to 1. So 3 to 1 into 4 कर रहे हैं हम. 4 1 जा 4, 4 2 जा 8, 4 1 जा 4, 4 2 जा 8, 4 3 जा 12. Again, this number should be read in the reverse order: 1 2 4 8, 1 2 4 8. The output is same. ठीक है? In arrays, we are going to multiply like this in the left to right order because it is easy to compute. Because it is easy to compute. Are you getting this logic? ठीक है, all right. So, see guys, the product will be now nothing but the product of array of I into that number plus some carry value. Okay, initially the carry is going to be 0. Then I can store this product modulus 10 in the current index, and I can send the carry forward. Carry is going to be this thing, product upon 10. Okay, are you getting this? Let me give you one more example. 1 2 3, and I'm going to multiply it by 15. So 15 ones are 15, product is 15, and we are going to store what here? We are going to store 5 here. So 5 is nothing but 5 कैसे निकलेगा? Product modulus 10. 5 comes here and 1 is carry forward. So 1 कहाँ जाएगा इस पे? 15 2 is 30. 30 plus 1 is 31. 3 कहाँ पे जाएगा? यहाँ पे. 15 3 is 45 and 3 48. And number क्या बचा? 4. So 4 will come here. So whatever the carry is left, this is the left out carry. Left out carry. It could be bigger number also. Let's say 15 nines are 135. In that case, 15 will 5 will come here and 13 will be the carry. So what we have to do, we have to place this number here, 3 here and 1 here. Carefully look at this. If the carry has more digits, if the carry has more number of digits, then we have to extract digits from the carry and place it at the ith index. Then I will go to this position and we will place the next digit unless this carry becomes 0, right? So we have to save the left out carry digit by digit. Okay, so here I'm going to use one while loop for the left out carry. So handle the left out carry. We are going to write, while this carry is not equal to 0, we are going to write a of n. N denotes the position, carry modulus 10, and I'm going to do carry equals to carry by 10 and n plus plus. All right, that's why I was taking n by reference, because n is moving ahead. N is moving ahead. Rajat, it's saying it is always having a carry as single digit. No, this is not the case. Suppose you are multiplying this number 2 to 9. Let's say number is 2 to 9 and the multiplying by 15. So 15 to the 30, your carry becomes 3. 30 आया, this goes here and 3 becomes the carry. 15 to the 30, 30 plus 3 comes 33. This comes here and 3 goes the carry. 15 nines are 135 plus 3, 138, and 8 comes here, 13 is the carry. So how will you store 13 here? So you will pick 3 and put it here, because this position is the n. Then you will increment n will come here, number left is 1 and you will put 1 here. This is what I have done using this loop. I have saved the left out carry at the required position and I have incremented n. N is now 5. N is now 5 because it contains 5 digits. Are you getting now? Akhil is saying, what is the need of n cannot be do unless it becomes 0. See Akhil, there could be some digits in your array which could be 0. It is quite possible that your output is like this, 15070072. Then and again there are some leading zeros. So how will you know कि you have to run your loop till here? Because these elements are also 0. So we need to maintain n, which denotes the number of digits we have stored so far in the array. Alright, Akhil? Now we have already written the multiplication logic. Now it's time to print the digits in the reverse order. Alright, we know there are n digits and the final answer is in the reverse order. So what we can do, we can do like this. For int I equal to n minus 1, I greater than equal to 0, I minus minus, and we are going to simply output our array. And followed by, let's say, one handle, and in the main I'm going to call my function big factorial of, let's say I want to compute 100. Let's start with a small factorial, let's say 5 factorial or the 6 factorial, and let's run our code. Yeah, so the answer is 720. It is working for the smaller numbers. Let us also try for some number like 100. So it is very big number, 93326. So this is a very big number. It has around, let's also print the number of digits. See out handle and see out how many digits it has. It has n digits. Yeah, so it has 158 digits, you can see. So I think it is working fine for 100 factorial. This is how you calculate big factorials in C++. Yeah, we are coming to the big integer very soon. Okay, so let me now come to big integer class. You have seen it becomes quite complicated in C++ when we have to work with these big numbers if we do not use the boost library. So I'm going to show you how you can use Java for this purpose, or you can also use Python for this purpose. Okay, so in Java you have a class called the big integer class. There is a class called the big integer class which helps us to do a lot of operations on big numbers, maybe GCD, maybe factorial, maybe modular arithmetic, maybe next prime you want to compute. All right, so I'm going to show you some examples of the Java big integer class. All right, so all set for the Java big integer. All right, so let's start directly with the code. These are the some of the functions that this class can do. Yeah. So we are now going to see the big integer class. Code link is being shared in the chat. You can get the code also. Now this is a basic hello world program in Java which is given by default here. Class. So in Java everything is a class, and suppose I want to play with some integers, I can make one method called um, static void play with integers, right? Static because I do not want to create an object to call this method. I directly want to call this method. There is one method, static void play with int. So let's say, let me include the scanner, like seen, like we have seen in C++, we have a scanner in Java, and java.math.biginteger is the class which helps you to work with big integers and do pretty cool stuff. This is very helpful in your programming competitions. At it saves a lot of your programming time on working with big numbers. So let me instantiate an object of scanner. That can be done using this syntax, system dot. This creates a new scanner. It's like a C in C++, right? And suppose uh, I want to read some integer. I can say int s1 equals to sc dot next, scanner dot next. Read whatever next is there in the buffer. Let's say 10. And I want to print the square. So I can write system dot out dot print ln s1 into s1. And just going the basic input output in Java, then we will see. Oh, just we are doing some basic input output, and here I will call my function play with int. Next int is the method. Yeah. So to read integers, we use next int. So I gave one number 10 and I got the output as 100, right? So suppose I want to do something more. I want to create one big integer. So you can create a big integer like this. Let's say big integer 1. This is equal to new big integer dot 1. So it creates a big integer object whose value is 1. And you can also initialize a big integer from a string. Let's say there is a number like this. This will create another big integer. Let's say I want to print this one. So I can say system dot out dot println. I think there's there is some different way of initializing this. You can write like this: big integer and here one. This works fine. So you can create a small number. You can create a big number also. You can also do 2 plus 1. But to do this, there is a function called add, and you can give this one. So on the big integer object 2, you're calling a method called add, which is adding another big integer called 1 to this integer. Let's see. So you can see this output becomes now 11. Earlier it was 10 in the end. Now it is 11. Yeah, we are working with maths only. Okay. There are, let me try a few more examples. Suppose I want to read a number. I want to read a string as a big integer. Okay. So let's say big integer 3, new big integer, and let's say I can, I want to read it from the console. So I write string s2 equals to sc dot next. Okay. And let's say next big integer is 1001. This will be read as a string. This will be read as a string, and here I can write, create a big integer from the string s2 which has been read from the input buffer, and let's try to print it out. So you can see this is the number, right? Suppose you want to read it as a binary number. This class also allows you to convert the base, right? So the second argument is the base. So by default it is, the base is by default 10. Suppose you give it 2, it means this is a binary number. This will be treated like a binary number. Now when I will output it, you will get a different output. So you got 9. So this is how easy it is to change the base using big integer, right? So you read the number as binary. It is very easy, right? Suppose you want to multiply two numbers. Let's say big integer बोल देते हैं 4, and suppose I want to do 9 into 4 which is 36. ये मेरे को करना है, ठीक है? और मे बी दो नंबर्स हम रीड कर लेते हैं, S3 बोल देते हैं, एंड यहाँ पे एक और बाइनरी नंबर दे देते हैं. तो 4 इज रिटन लाइक दिस 100 को रीड कर लिया, ठीक है? एंड आई कैन से एक और बना लो, बिग इंटीजर एक और बना लो, तो हम B4 बोल देते हैं, B4 which is again a new big integer initiated from S3. I can do system.out.println c dot, or maybe you can write something like this, 3 equals to 3 multiply by another big integer B4. And we are going to print now 3. System.out.println 3. Yeah, so output is 36. So you have read two binary numbers, treated them as decimal numbers, changed their base, and multiplied them. This also works for the binary numbers. If you write 8 here, this will become a octal number, right? If you write 16, this will become a hexadecimal number, right? Suppose you can try, right? You can try. This is 111, maybe 119, and you can read it as an octal number as well. So you just need to mention the base here. So similarly, you can do addition. If you want to do addition, you can do 3 dot add, something. Let's say the number is 2. This will do your addition. You want to divide, you can write 3 dot divide by, let's say, 2. This will do your division as well. Yeah, this is something you can try on your own. Now let me come to one important property of important function of big integer is computing GCD. Let's say string, yeah, big integer b0, new big integer with initialized as 15, big integer b1. Let's say this will be in quotes, right? Suppose you want to initialize a big integer from a number, from a number, then you have to use this method. You have to use this method called big integer dot value of 5, right? So value of method converts long int into your integer. तो स्ट्रिंग से करना है, डायरेक्टली इनिशियलाइज हो जाएगा. वैल्यू ऑफ से करोगे तो वो एक इंटीजर को एक बिग इंटीजर में कन्वर्ट कर देगा. एंड सपोज आई वांट टू कंप्यूट देयर जीसीडी, सो आई कैन डायरेक्टली राइट system dot out dot println, and gcd is nothing but the p1 dot gcd with b0, राइट. दोनों को हमें gcd मिल जाएगा. तो देखते हैं what should be the gcd of 15 and 5. लेट मी, आई थिंक इसको हम ऐसे नहीं करते, इसको हम डायरेक्टली ऐसे लिख सकते. We can write it like this. This returns a big integer only. Yeah, so gcd of 15 and 5 is 5, which is correct. And let's say, let me change the number. Let's say 20 and 15. 20 and let's say 12. The number is 12. I want to compute the GCD. So you can see the GCD is 4, which is coming out to be correct. Alright. So you are getting GCD, how this works. Now there is one more method, which is the next probable prime. So this automatically generates your next prime number. So I can write system dot out dot println. I can write, I suppose I want to see the next prime number after 20. What is the next prime number after 20? So I can write v0 dot next probable prime. So it should be 23. 20 के बाद जो number आता है prime number, that is 23. So you got the output as 23. Is it cool? I'm giving the demo on small numbers. You can do it for any big number, 100 digits, 1000 digits, million digits. All right. Okay. You can also do bitwise operations. Suppose you want to count the number of bits. Count the number of set bits in, कितने set bits हैं इसमें, ठीक है. So you can write system dot out dot print ln. किसमें चेक करें? लेट्स से 12 में चेक कर लेते हैं. तो 12 में कितने set bits होते हैं? There are 2 set bits in 12. So 12 है b1, b1 dot bit count. Bit count is one method which counts the number of bit bits. So you can see the output is 2 because in binary of 12 only 2 bits are. All right. Now using these properties we are going to solve one problem from Spodge. Let's try to solve one problem using big integers from Spodge. Okay. So this is a relatively easier question. I think you will be able to do it. But before that, let me also show you how you can write the factorial code, right? So suppose you want to compute factorial, so you can make static one function which returns a big integer, and you can name it factorial in 10. And in this function, you need to create one big integer p, which is new big integer with initialized as 1, and I'm going to multiply all numbers from 2 to n with this number, right? I plus plus, and I can say b equals to b dot multiply another big integer which is I, which is created using I. You cannot give the I directly here because when we multiply we need to have two big integers, and I can also return this big integer formed. I can say return b, and this function, the main function, you can call your factorial function system dot out dot print ln factorial of 100. So it is the same output as we got in the previous C++ code. So you can see how easy it is to write a factorial function in Java using big integers. So you guys are getting the stuff. Any issues so far? Kunal, I have already. Acha. You can also, suppose you want to read a big integer, right? So what you can do is you can use this method called sc equals to um, right, a big integer b equals to next sc dot next big integer. I think this is the method which reads a big integer from your console. Suppose now you give here 100 and you give b here, and now I have to make it big integer also. This is the method to read a number from the read a big integer from the console. Yeah. So now this loop will be also start from this will be again a big integer, right? This you can fix. We are moving on to the problem called Julka on the Spodge. So this is a very simple question. In the question, what it says, you are you can go through the problem statement on your own. I'm giving you 2 minutes to go through the problem statement. Rishabh, to save time in contest, you have very less time to execute your program. To to give you an edge to save time, compare time complexity. So inbuilt functions are pretty fast. It is linear in terms of your number of digits. Number of digits के proportional होगा. Yeah. Next big integer is the method I have already taught. The question says you are given a value of n. There is a girl called Julka, and it is given the number of apples is 10, and you are given a value of k, right? So you have to divide these apples into two sets such that if the first set has x apples, then the second set has x plus k apples. All right, this is the question. So you have to tell me what is the value of x and x plus k. So suppose n is 10 and k is 4. Clearly you can say the division is like this. Let's say k is 2. So one answer is 4 and the other answer is 6. Because 6 plus 4 is 10 and 4 plus 2 is 6. This is a simple question. So you can say if the first girl has x apples, then the second girl has x plus k apples, and sum of these apples is equal to n. So it is basically 2x plus k equals to n. In the question you are given 10 test cases, and for every case you are given the value of n and you are given the value of k. The only thing is these values are very large. These values are very large like this, because in the constraints it is given both the numbers are of the order 10 raised to the power 100. It means number can have 100 digits which we cannot store in int or the long int. We are going to use big integer to solve this problem. Okay, so uh, you can get the idea of old code, which is 1759. Okay, now I'm going to write one more method. I'm going to remove this one, and let's say static void compute whatever the answer is. This method takes two integers n and k and does the work for us. Going to remove this code as well, and for the spodge it is given you have to take 10 test cases. All right, so let's say big integer n, k, and answer I have. Number of test cases is given as 10, and while these test cases are greater than 0, we are going to read the value of n. So scanner sc equals to scanner from dot n and test equal to test minus 1. N equal to sc dot next big integer. We are going to read the first integer and then the second integer. K equals to sc dot next integer. Should be next big integer. And we are going to call this function compute n and k, which is going to print our answer for the given value of n and k. See, now the question is, you have to perform this computation. You have to do this thing. You are given a n and you are given k. Let's say k is. So the equation is, first girl has x apples, second girl has x plus k apples, and total there are n apples. This becomes 2x plus 2x equals to n minus k, and x equals to n minus k by. So this computation we can do easily using the big integers, right? So first we have to subtract k from n, then we have to divide it by 2. So we will get the value of x, and the second value will be nothing but x equals to x plus k. This will be the y value, right? So I can say x is equal to nothing but n dot subtract k, then x equals to nothing but x divided by a big integer which is initialized using 2. And then I can say y is nothing but y is x plus k, y equals to x dot add k, and in the question is asking about the values of x and y. System dot out dot println y and x. All right. So let's name it as class Julka. Let me run the code for few test cases. Let's say I'm giving only one input, 10 and 2. Or let's make all these inputs like this. Now let me run it. Oh, so spelling mistake. Subtract. Okay, this should be big integer dot value of 2. Otherwise we have to use the new word, right? Yeah, so you got the answer 6464. Now let's try to submit this problem on Spodge. We are using Java for the same. Yeah, so it got accepted. Right? It's my old account. So right. All right. So one last thing. Uh, you can also use Python to do the work. You can note the ID. It is 1765 for the Julka problem. 1766 also works. So we have created few problems for you guys on hacker blocks also. Yeah. So this is a contest which all the students who are joining this program have to attempt. Link will be shared you guys. This is the first assignment for after today's class which you have to attempt. Link will be shared with you guys, right? You have to sign up on hacker blocks. Everyone has to sign up on hacker blocks. Then in the all those who have enrolled will be given the link. practice problems. Apart from it, there are questions in the practice section as well, which you can try as per your ease. Now we are going to move on to the next topic after a short break, which is the standard template library in C++. But before that, I'm going to show you the Python code as well, which is pretty easy to write. You can also use Python to work with problems involving big integers. Yeah, I think you have, but some of the contests restrict you from using Python. But suppose you want to define one function called factorial, which computes, let's say here answer equals to 1 for, let's say, I in range 1 to n. I want to do this thing, answer equals to answer into I, and I do print answer. That's the simple factorial function in Python, and I can call fact 100, and there won't be a semicolon here. Let's run it. So you can see you got the output. This is same as the C++ code which we have done. So very short, very quick. Sometimes what happens is Python is little slow, so it might not get accepted, but for most of the contests, Python will also work. We are going to cover this course in C++ because it is the most preferred language for competitive coding. Most programmers use C or C++ because it is closer to the hardware and more efficient, right? So for those people who are going to do this course in Java, they can use Java collections framework. But we will teach you today the C++ framework for all the data structures that are there, right? So when we continue maths in the next class, we will talk about binomial coefficients, Catalan numbers, applications of Catalan numbers, then your linear matrix exponentiation, some problems, pigeonhole principle. We will discuss inclusion exclusion principle, one of the hardest problems from Code Chef Long Challenge, Reja and LCM. This we will discuss, and we will also talk about mathematical expectation in the next class, right? So we are now moving to the second half of our session. All right, we will talk about other topics as well, number theory and all that stuff. The next two classes. So I am handing over the control to Deepak Bhaiya, who will join you. आ जाना मिलवा दूं. So Deepak Bhaiya is here. He is going to teach you the C++ standard template library. All right. Okay, we will have a short break of around 7-8 minutes, right? We will have a short break of around 8-10 minutes. We will start at 9:03, right? There is a 10-minute break. Okay, there is a 10-minute break to bring food. So Rajat, all the problems that you need to solve, here I'm going to share the link.
So, hello friends, a very happy Dashera. So, today we are going to learn in this session STL. So, there's a saying called why reinvent the wheel when you don't have to. So, what is STL? Let us understand that. So, STL is standard template library. Standard, standard, as we as we all know that for an example we have standard for everything, standard for weights, standard for electric plugs. Similarly, there is an ISO standard for C++ as well. So it means that if a C++ program is standardized, then I can make sure that it is available on all the standard compliant compilers. For an example, for an example for example I have STL. So standard template library is basically a group of files that is available on the standard compliant compilers. It is standard because ISO tells every compiler maker that it should be given with all the compilers. Template because it is a templated one. We learn how to make our own templated class, our own templated function, and library because it's a collection of library. Every language has its own STL. In Java, we have a JCF, which is Java Collection Framework. So STL is a large piece of code that every compiler must supply so that every programmer can rely on it. As somebody was asking, like, why can't we use Boost? So Boost is not a standard library. It might be that you have installed Boost on your computer, the other person haven't installed Boost on his computer. So the code will compile, the code will run on your computer, but might not run on the other person's computer. That is why we cannot use a boost in programming competitions because it is not available on every PC. Now, what does a computer deal with? A computer deals with data, algorithm, and data structures or containers. So, so let us see how data and algorithms are bound together. For an example, I have a function. So let's say I have a function which takes an array and prints the data. So the input is an array and printing the array is the algorithm. So array, the data and algorithm are bound in such a way that you cannot use data of one type function created for data of one type to another. What I mean to say, I'll show you by example. So for an example, let me write a function called print. Void print array. It takes an integer array and it just simply prints it. I creates an array and it will definitely run. There is such a trivial program. So 1, 2, 3 has been printed. But suppose I want to write this character array, and now I try to compile this program, it will give me an error. Compilation failed with exit code 1. Why? Because this data, this data is bound with this integer. So print array, the functionality of printing an array should not rely upon whether it's an integer array or whether it's a character array. Printing means koi bhi array ho, we have to print it, be it a character array, be it an integer array. So we can make it free from such kind of foundation using templates. So I will not define a function, rather I will define a template through which a function can be generated. So to do that, I will write the keyword template and say I will write t, where t represents a type. So abhi we will not print array of integer type, we are going to print an array of t type. Now n is the number of a number of elements in the array, so it has to be an integer. So now if I run this program on for character array, it will get compiled, ABC will be printed. Now if I try to run this program on integer, the same code runs for the same function now runs for the integer array as well. So I hope this makes a sense, because printing an array and the data type should not be bound together. Algorithm is separate and the data type is separate. So using template, we have seen how we can separate data and the algorithm. Hope this makes things clear to you. So we have understood generic programming using templates. So now I shall say templates allow us to use same functions over different data types. Or I can say functions are general. The second case is data and container. So what containers actually are, as we say, an array. So an array can hold, an array contains elements, a list contain nodes, a hash map contains key value pair. Am I right? So all these data structures are containers because they contain data. So instead of data structures, I will use the word container. And if we think, um, if we think for a while, we will understand that data and container are also bound. How? I'll show you through an example. Say I want to make an integer array. So how will I make it? Or I should say, let us make a stack. I hope everyone understands stack. A stack of a stack is a data structure on which you can insert from a top and you can delete from top. Only top operation is permitted. So in reality, there is no concept of stack. You will never find a stack. You will always find a stack of books, a stack of plates, a stack of cache nodes. So the stack property is similar for plates, for books, for cache nodes. The date, the container and data are also separate in logical terms, but because of this foundation, because of computer foundation, we are not able to perceive that perceive that logical indifference with our computer code. So how we will achieve that differentiation, that containers and data are separate in one term? I am going to show you that. So say I make a stack S. So stack is a predefined library in C++. To use that, I will include stack header. Now stack S says S is a stack. So stack doesn't exist in the world. So I have to say stack of integers. So using this parameter, I am telling computer ki create a stack of integers. If I write stack char, then stack of character is introduced. So just by mentioning these templated parameters, I am able to have the same data structures for different kind of data. So this way we achieve uh, independence among data and the container. So containers can be classified into three parts: sequential, associative, and adapters. So sequential containers. Sequential containers are those containers in which the sequence matters. The data are stored in a particular sequence or the position matters. So can you give any example of sequence containers, sequential containers? So you guys are advised to participate in the discussion. Any idea what sequential containers could be? What else after arrays? Oh, vector. Yeah, great. Other than vector and arrays? Map. Okay. So we have few answers. Somebody says array, somebody say vector. So vector is nothing but a array like object. sequence matters. The other one is list. The sequence matters. If I insert C, it might get inserted at C, it might get inserted before A. So sequence matters. Forward list is another type of list in C++. Deck is a doubly linked list. Oh, sorry. It's a queue, a doubly ended queue. Array is nothing but a simple array. Now the other one is associative container, in which the user doesn't know where the data is inserted, but the data is somewhat associated with itself. So somebody said that map is a sequential container. Map cannot be a sequential container because key and value are bound. You don't know where this pair will go. It just simply goes into the map and uh, get position of itself there. So data is somehow associated with itself in associative containers. Position does not matter. In a map, if I insert, say, i- if I say I insert, if I insert A comma M, then it might get inserted anywhere irrespective of the position. Whenever I say I require the value which is corresponding to A, the map is going to return that value to me. So I cannot refer any data using any location. I have to refer using data. Only that way I can use a map. Same goes with multi-map, set, multi-set, unordered map and unordered set. So these are the containers in which you don't have the concept of indices. You cannot say, yeah, give me this data at this particular location, because you don't know what the location actually is. The other one are adapters. Adapters are not containers, but they sit on already existing containers and restrict their functionalities. For example, queue. A queue is just a concept. When an queue restriction is implemented or is posed over an array behaves like a queue. When stack restrictions are imposed on an array, the array start behaving as a stack. So So we can say that adapters are not containers, but they get imposed on already existing containers so that container could behave like an adapter. I hope this makes things clear. So they are pure concepts. For an example, stack, queue, and priority queue. So these are few data structures. These are the data structures that are provided by the STL to the user. Algorithm plus container. Now let us try to write a function, uh, try to write an algorithm of finding an element in an array. Or let me take a simpler example. Um, Before that, let me introduce the concept of iterator to you. Suppose I have an array, and let us take a simple example, print array. So I'm not writing the function, array will be printed, and I will create an array and I will say print it. That's all. And it will work superbly. Now what? If I say I want to write a function that prints the container. So instead of printing an array, I want to print a container. For an example, I want a function. If I give that function a list, the list will be printed. If I give that function a array, an array will be printed. So the algorithm of printing container is same, but the container itself is changing. So how can we achieve generality over this concept? Are you getting what I'm trying to express? That earlier cases the data and algorithm were bound, now the container and algorithm bound. The container here is an array or list, and the uh, algorithm is the printing of that container. So we can achieve this generality by seeing a concept that there are no containers at all. So we are going to eliminate the concept of containers from our mind, and we are going to use the concept of ranges. So there is no container for us, there are only ranges. So I will not say ki print array, I will say print anything that lies between begin to end. So that beginning could be beginning of of an array. That beginning could be beginning of a list. That beginning could be a beginning of a map. So that beginning, we don't know what the beginning is, but we know that we have to print data from beginning to end. I hope this is making sense to you people. So this is achieved, this the concept of this range is achieved using a very powerful mechanism called iterator. So iterator is pure concept. So iterator is pure concept. So I say you have to print from beginning to end. In C++, we have concept of ranges using this mechanism. The beginning element is included and the end element is not included in the range. So if I say print the element between beginning to end, so basically I am going to print these these six elements and not the last one. So if I give I will say ki 0, say if I want print elements from 0 to 5 both inclusive, I have to give range as 0 to 6. I hope okay. So this is something a factual sort of thing. Secondly, a pointer to an array would be an iterator. So just think of a logical pointer. You have been you are standing here and your friend is standing here, not here, but here, and you say I will move one step ahead and I will print the data. Okay, so you come here, you print the data. You come here, you print the data. You come here, print the data. Come here, print, and so on. So you just know that you will stand on some position and print the data and move ahead. So this moving ahead should be implemented by an iterator. So anything that implements such functionality that it can stand on a container, access the data and prints it, or just access the data and do whatever it wants to, then we call that concept an iterator. So anything like an iterator is an iterator. I hope this is clear. So we have few categories of iterator. This will help you understand it really well. Input iterator. Input iterator are those iterators using which you can only read the data. Using which you can only read the data. So tell me an instance, tell me a device where you can only read and you cannot write on that device. Just tell me. What kind of device you can only read from and cannot write to? String is not a device. Just think in terms of device first, then I will move it to the container. Okay, what about keyboard? Can you write on a keyboard? I think no. So we can only read from keyboard. So any iterator that is attached to your keyboard will be an input iterator because it can only read the data and move ahead. Read the data and move ahead. Same goes with the output iterator. So device with which you can associate an output iterator is monitor. Absolutely perfect, Pranit. So मॉनिटर पे सिर्फ वी कैन ओनली प्रिंट द डेटा. सो these two, so input we can read the data, output we can print the data and move ahead. If we can read the data and print the data simultaneously on a single device, then we call it as a forward iterator. Any example of a forward iterator? Forward iterator, so list, so file, your doc file, word file, all these are files through which you can read, through which you can write. So forward iterators are those iterators which allow you to write on a container and read on a container in a forward direction. So if I say, so say I have a container, I can read from him 1, 2, 3, 4, 5. So say I can read one, then I can move ahead. I can move ahead. I will read 2, then I can move ahead. So move ahead means I can perform this plus plus operation. Now I can write 3 here. So this this pointer is nothing but an iterator. So if I can do this only in forward direction, I will call it as a forward iterator. If I can do this in both direction, I will call it as a bidirectional iterator. So I want you to tell me which containers will have only forward iterator. Which container will have only forward iterator? Any guesses? Correct. So Akhil is absolutely correct. If linked list will have only forward iterator. Okay. If the linked list is a doubly linked list, then that same list will have a bidirectional iterator. So just tell me what could of iterator will arrays have? Arrays के पास कैसे iterators होंगे? Forward और bidirectional? So I want to answer for vector. I want to answer for arrays, iterators to an array. कैसे arrays के पास iterators होंगे? Both. So both means I hope you guys are getting absolutely right. Somebody is saying both. So I can say if iterator is a bidirectional iterator, so bidirectional iterator is a superset of forward iterator. If an iterator is an input iterator and output, so forward iterator is by default an input iterator and output iterator. So if an iterator is forward, I can say that it satisfies the properties of being an input iterator. If a iterator is a bidirectional iterator, then it satisfies the properties of a forward iterator. And then we have the last kind of iterator, that is a random access iterator. So random access iterator can take jumps. So if I'm at position 0 and I say ki move to the position 5, then I can move to position 5 only and only if it's a random access iterator. Otherwise, I have to go to the 5 one by one. I cannot jump. So arrays, vectors, and these kind of objects have random access iterators. Linked list, maps, sets have bidirectional iterators. and we'll see forward iterators. So why I'm telling you all this stuff, because this really helps you to use STL. So I am going to tell you two websites using which you are going to learn STL on your own. So let us move to websites. One is c++.com, the other one is cppreference.com. So I hope this website, you people are able to look at the website. There is a section called information, skills, reference, articles and forum. So we will always go to the reference section. So reference section, we have this grouping of logical grouping of the concepts. So say I want to use a function binary search. So that function is defined in the class algorithm, and I will say I have to search for binary binary search. So now binary search requires a forward iterator, it requires a forward iterator last, and it requires a value that should be searched. So now tell me, is vectors a suitable container for binary search? Is linked list a suitable search for a suitable container for binary search? The answer in both the cases is yes, because binary search require forward iterators, and lists and vectors both have forward iterators. And if you want to look at on average logarithmic in distance between first and last, on non-random iterators the complexity is n, and on a random access iterators the complexity is logarithmic, as we know that binary search can only happen on arrays in log n if we can have jumps, if we can if we are able to find the middle element. So let's learn by doing. We'll write a function to remove element from an array. So given an array, you have to remove element from an array. Say you have an array. Say I want to remove all the elements that are smaller than n. All the elements that are smaller than say 20. Okay. So either I can write a for loop or I can use STL. So I will go here, I will check on algorithm, and I will try to see key does there is there function, do we have a function called remove? Oh yeah, remove value from a range, remove elements from a range. So we have to remove all the elements that are in the range. We'll click this remove if. So we require at least forward iterator. So if an iterator is a forward iterator, bingo, we can use this remove if operator, sorry, remove if function. And here it is written that we require a unary predicate pretty. So what it is, unary predicate is basically a simple function that will take an element and will return a value convertible to bool. So what I mean by this, I'll explain it. So I want to remove all the elements that are smaller than 20. How can I achieve that? I will say remove all the elements that are smaller than 20. So how remove if function is going to understand our language, we have to pass a function that will tell our uh, that that will tell remove if ki these are the potential candidates to be removed. So we are going to write a predicate. It accepts one element and returns yes or no. Yes if the element is to be removed, no if the element should not be removed. Okay. So I am going to tell it this way. Remove if remove all the elements within the range array to array plus n using the function say say foo, or foo is not good, we'll take remove bad elements, or I should say is is be removed. So is to be removed is a function which we'll define. So is to be removed, it accepts a number, it's accept an integer because our container contains integers. Array is our container of integers. And if n is less than equal to 20, we will say just remove it, or otherwise don't remove it. I hope this is clear. So is to be removed is called as a predicate because it called a predicate because it returns a boolean value. It is unary predicate because it accepts only one argument. If if it accepts two arguments, we will call it as a binary predicate, which will look. And now I will try to print the array. Yes, remove is not defined because we have not included algorithm there. Try to run. And now it is waiting for the input. So I will enter 5 elements 20, 12, 99, 14, and see 99. 99 is the only element, rest all are removed. They all are being shown because we have run our loop 5 times. So the actual element is just 9. If because I know that there are 4 elements that are less than 99, so I should just print it to 1. If I just print one element, I will have 99. Okay. So remove if doesn't modify the size of the array. It just removes the elements from beginning to end. This way we can remove elements. So I hope the, the reason to discuss this function is explain the concept of unit predicate. Now reverse copy. Suppose you have an array and you want to copy it to another array. So how you can achieve this? So this time we will not take arrays, we will take vectors. A vector. Uh, at Praneeth, see Praneeth, elements were deleted. That is why initially we had 2, 20, 99, 14, etc. and say 7. So elements were deleted, 2 was deleted, 20 was deleted, and 99 came here. 14 was deleted, 7 was deleted. So these four elements were deleted, and in the array we printed from 0 to 5. But in practice, in actual, the right practice should be we should only print the all the elements that were there in the array. The array there was just 99, but we printed the array from 0 to 5. So that was our mistake. So remove function push deleted, or I should say it overwrite the elements that were smaller than 22. So in computer we cannot have delete operation. So we always overwrite the things. That is why you l- you tend to observe 20, 99, 14 and 7. So 2 was overwritten by 99, and 20, 99, 14 and 7 were untouched. I hope now it is clear. uh, you need not to know that, because in vectors and every other stuff, remove if or we have another operations like erase and other functions which will actually remove the element and will decrease the size of the container. Remove if doesn't modify the size of the container. This you will get by reading the documentation that from the sites which I have told you. See, you will get used to all this kind of thing once you practice 2 or 3 questions. I'll show you. See, the function cannot alter the properties of the object containing the range of elements. So this is just I took this example to discuss the functioning of a unary predicate. So you should not use, means I'm not telling you you should always use this function to remove an element. We'll see other function as well. I The purpose of the question was, did you understand how to use a predicate? So let us move to another question. This will make things more clear. The question is, you have been given an array and you have to copy it to an another array, but in reverse order. So when I say array, I will use it interchangeably for vector. So how can I achieve this? Either I can write my own function, my own for loop, or I can simply use STL for this purpose. So for that I need to know which function perform this job. So I will go here and reverse copy. Yeah, so I can see one function. These functions are those functions which are used extensively. So I know these functions. When you get used to all such kind of things, you will also learn all these functions. So first, last, and result. So first and the last is the range that need to be copied, and it should be stored in result. So I will have a vector of say characters. I will show 10. I'll input 10 characters, and then I will copy it to another vector. First copy, start from b dot begin v dot begin gives you the iterator to the start of the vector v. V dot end, I have to copy the whole range. These two are the iterators provided by a vector class, and I have to copy it to the beginning of v2, and then I will print it. I will input 10 characters A, B, C, D, E, F, G, H, I, J. Will run it. See, without any error, we reverse the array. Now v2 contains A, B, C, D, and so on in the reverse order. So this way STL can help us write very efficient codes in very less typing. And now I think this the concept of iterators, predicates is clear with you. Now we'll try some spot questions. But before that, I want to specifically mention this next permutation, and I want to show how this works. So next permutation basically gives you the next lexicographically greater permutation of the current sequence. So say I have a vector of integers. Say I have 5 elements. So v0, say, or I will input. And now I ask ki just permute, just find the next permutation of the given array. So I will call next permutation. There is no container for algorithm, there is just ranges. So permutation of the elements between the range begin to end, and so it requires bidirectional iterator. Vector, yes, they do have bidirectional iterator, and I have to just supply first and the last range. So, and now I will try to print the vector. So if the vector contains 1, 2, 3, 4, 5, what is the next possible permutation? What is the next possible permutation? So next possible permutation, Tulsi, yes, vector can be deleted using the clear function. 2, 1, 3, 4, 5. Okay, so Kunal is absolutely right. 1, 2, 3, 5, 4 is the next lexicographically greater permutation, because if I arrange this in dictionary order, so 1, 2, 3, then 5 will come and then 4 will come. So I will run it, and bingo, without any backtracking or any recursion, I can have I have the next permutation of the given array. So I can have permutation of integers, permutation of characters, permutation of strings, whatever I want, just by using this simple function. So very powerful function. We'll use these functions for solving n queen problem as well. The second thing is, I want to emphasize is like telling you people that a vector is having a bidirectional iterator, random access iterator, and linked list is having a bidirectional iterator. So how would you come to know the container consists of which kind of iterator? So for an example, I want to know the iterator for list. So I will just click on the list. The so this is a list header. Inside header I have a class called list. So list is the class, and this angle bracket is the header. So inside list I will go on iterator. Every container class page has this kind of a table called member types, and in iterator I will just look a bidirectional iterator. So I can make sure that list is having a bidirectional iterator. So in C++ STL, list is implemented using a double linked list. So priority queue is nothing but a heap-like structure where you can access an element based on some priority. So the queue header contains two classes, queue and priority queue. So we will look into how priority queue is formed. So I want a priority queue of say integers for now of integers, and I will name it PQ. I will insert two elements, PQ dot what is the function of insert? I'll go down push. So push inserts a new element, PQ dot push say 2, PQ dot push say 3. And let's see whether this priority queue is a min priority queue or max priority queue. So it's a min heap or max heap. I don't know. So let us try pushing, seeing the top element. So if 2 is printed, then I can make sure that the priority queue PQ is nothing but a min heap. The minimum element has higher priority. If if 3 is printed, then the default priority queue is a max heap. Now I have to import STL libraries again and again again. So what can I do? Instead of doing all this stuff, I can import one library which contain the list of all the standard library. This is called std slash bits slash std c++.h. So this is a standard header that contain list of all the STL libraries, and this is most oftenly used by competitive programmers. So I recommend you using this only for competitive programming purpose, not for project development. And now I will compile it and see. I got 3 as the output. So the default priority queue is a max heap. What if I want to make this priority queue as a min heap? So I will look into the constructor, or before that it says that class priority queue is a templated class with t container and a comparator. So t is the type of element it is going to store, container is the type of container which is going to use, because priority queue is a adapter, it's not a container in actual, and compare is a binary predicate that take two elements of the type t and returns a bool. So I am saying store integers using vector of integers and a comparator. So it will take two integers a and b, and will return and will tell ki that element should appear before uh, uh, if this is a container, this is a vector and it stores 2, 3, 4, 5, 6. So which element is removed? The obviously in a priority queue or in a heap, the last element is removed. So if 6 is at the last, I will say 6 has the higher priority. So if the vector would have been, if the lower element is having the higher priority, it will appear at the later point of time, or at the later index. If it has a smaller priority, it will appear at a higher at lower index, means 0, 1, 2, something like that. So I will say if A, now which should appear before. So I will say if A has higher priority, then A should appear after B. Am I correct? So I can say if A is less than B, means smaller element is having higher priority. I want that because right now higher elements have small higher priority. So if A is less than B, then return false. Otherwise, return true. If A has higher priority, then A should appear after B. Comparator returns the answer of this particular thing. This is the answer that our comparator function answers always. So should A appears before B? No, A should not appears before B if A is less than B. So this way we have written a comparator, and now if I try to compile this program, this will not compile. The program will give me a compilation error. This is very important to note because the priority queue says I want a class compare and I don't want a function compare. So if I want to make a class that contains such kind of comparator, I am going to encapsulate this class in a structure. So this is something we have to memorize. So struct, and I will name it say comparator, and inside this comparator class I can give it any name, comparator xyz deepak coding blocks, whatever I want, and I have to overload bracket operator. The operator that should be overloaded has to be this bracket operator, otherwise it will not work. So now the comparator, earlier the comparator was a function, now the same comparator using structure has become a class. I hope this is clear. And now this program will compile, and answer is 2. So we have used STL to customize the max heap into min heap using this comparator function. So comparator gives us the flexibility to work on algorithms differently for different kind of data. So I think that's all theory. Now let us solve few questions on Spoj. So let us solve this question. And I want everyone to participate. You can use our IDE. The link is codingblocks.com/IDE. So the problem is there are students sitting in a class and a teacher. So Don and his friends has some sort of code word to describe girls who pass towards their class. So if Anita pass, somebody says, dude, 5-2 is going. So I can say the Somebody is asking us that why we use struct. Can we use class? Yes, we can use classes. It's one and the same thing. The only difference is if I use class here, so I have to make this method public. That's the whole point. If I run this, this will perfectly work. There is no difference. The struct has all the members by default public. The class has all the members by default private. So both are correct. So we can, it's like our taste, which one will we prefer? So the code for Anita is 52, the code for Chitra is 64, and code for Divya is 16. Now the input of the program is, we will be given code and and the person. So 52 is the code for Anita, 64 is the code for Yamuna, 64 4 is then code for Chitra. So 64 Yamuna and then Chitra. So we will say that the latest code, that the latest girl corresponding the code 64 is Chitra. So the answer is Chitra. Then Divya teacher and so on. So uh, once this input is done, we will be given few queries and we have to tell corresponding to this particular code what is the girl, name of the girl which we have to tell. So what could be the approach to solve this problem? I want few inputs from your side. I Keshav, absolutely perfect. So the logic is we want write our own how I'm a map of what I want. So code is nothing have. I will this pair of in a new, if I say type def, type a new type pair of has been given a new called II. So if I, am I audible? So if I say int new name and I want to write new name x. So this is same as writing int x. So now pair of intent is defined as II in our code. Am I audible? So I want a map of code which is a pair of integer, and I want to map this code with a string. So this is my table. So now these are the n codes that will be given to me. So for int I equals to 0, I less than n plus plus I will have a pair called code. So code dot first I'm going to input, and code dot second. So first and second are the public data members of the class pair. So I know this thing, hence I used it. If you don't know, you can always ask it on Slack and we can discuss such issues there. So this is something you need to learn. And then I will have the name. So let us create one more string called name. So I have the code for the girls, I have their name, and now I will map it. So table of code is equal to name. So I basically inputted that code. So for 4 2 I have Chitra now. So now I input the entry. I recorded the entry. So code name pair recorded. Great. Now I will be given few queries. So int few queries have been there. Now for every query I have to answer the name of the person. So I have done this part. I have done this part. I have input this. Now I will be given -2 and 0, and corresponding to that I have to input teacher. See, this type def has is really handy for competitive programmers because it really saves a lot of typing. So I will always recommend giving new names to the already existing types using type def. So if you are not used to, please start using type def a lot. This will really help you in the future. So uh, I will accept a code dot first, code dot second. So code has been read, and now I will simply output. I will simply output the name table, the name corresponding to the code will be output. And there we go. This completes the code. So let us try to run it on the given input. I have pasted the input. Now I will run it. Teacher and Chitra. And the expected output is it is teacher and Chitra. So we have solved a Spoj classical problem using few lines of code because we are able to efficiently use STL. So STL is a must for all the competitive programmers, and I will simply copy this code and paste it on the Spoj to see if it works or not. So we got it accepted in the first attempt. So that's really desirable for a competitive programmer. So we are able to do this because we use STL, and STL guarantees efficiency, it guarantees the correctness. So always prefer using such kind of containers. Master these containers. We'll give you a lot of practice material to master these kind of containers. And let us try another problem: the glittering caves of Aglaron. Let us try to solve it. So in this problem, you will be given, say I give you 2, 2, 1. So you will be given a pattern of 2 cross 2, and dot represents these all, these dot and these star are nothing but bulbs. And this is, I will say, row 1, this is row 2. So I have a switch connected with row 1. I have a switch connected with row 1, row 2. So each row has one switch. So I have to uh, and I have one chance, or I can at the I have to use um, one toggling of a switch so that I can have maximum number of switches on, maximum number of bulbs on. So is it possible to, and currently I am having two bulbs that are switched on. So if I toggle this button which is right now off, then these two bulbs will be switched on, and the total number of bulbs that are switched on are 4. So let me take one more example. Say I have input 3, 4, and the maximum number of available attempts are 2. 1. So which rows should I select so that I can have maximum number of bulbs switched on? The constraint is I have to use these two attempts. It means I have to toggle twice. I have to toggle uh, uh, two switches, exactly two switches, plus no. So if I choose this row, and so the state after toggling the switch would be this. Definitely, I'm not going to toggle this row because all are already on. And if I toggle this, the state would be this, right? So the maximum number of bulbs that I can achieve remaining switched on is 1, 2, 4, 5, 6, 7, 8. So 8 is the answer for this particular case. So how can I do this question? Any suggestion? Given a configuration to 1, you have to output the number of maximum bulbs that can be switched on. The constraint is you have to use these many attempts. Okay, I will explain the question once again. See, I have been given a configuration, say 2, 2, 1. So it means there is a matrix of 2 cross 2. This is row 1, this is row 2. Each row has a bulb, has a switch associated with it. So if I have dot, it means that the bulb is switched off. If I have star, it means that the bulb is switched on. So if I toggle this switch, so if I toggle this switch, what will happen? These bulbs will start glowing, this one and this one. And if I toggle this switch, these bulbs will stop glowing. So in once the number of attempts I can make is exactly 1. So I have to toggle exactly one switch and achieve such a state that I have maximum number of bulbs glowing. So once I toggle this row, I will have this configuration. Am I clear now? And so I have two glowing in the row 1, I have two glowing in the row 4, row second, so I have total 4 bulbs. Now take another case. Take this case. So I hope the question is clear. So if the configuration is this, and you have 3 attempts, so which or I should say you have, yes, 3 attempts. So which bulbs you will use, which rows will you swap? This one, and this one. After toggling all these switches, you will have this state, and the total number of bulbs that will be glowing is 1, 2, 3, 4, 5, 6, 7, 8. 8 bulbs, right? If the question was you have only 2 attempts, so I will choose this and this row. If you have 4 attempts, you have to use 4 attempts. So I will toggle this, I will toggle this, I will toggle this twice. So in the fourth, if I have 4 attempts, I will toggle this once, I will toggle this once, I will toggle this twice. So the state would have been like this. And I will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 glowing bulbs. So I think priority queue would be an overkill for this problem. We can think a little bit simple. So Saurabh, this is the last question. Once we after this we will wind up. So let us complete this question. So one very obvious strategy would be this. Very interesting strategy. So listen very carefully. See, I will be having, say this is the state and I have say 2 attempts. So what I'm going to do, I am going to have an array, and in this array, I will store that the number of bulbs that are glowing initially in each row. So initially in row 0, 2 bulbs are glowing. In row 1, 0 bulbs are glowing. Am I right? So now choose that row which is having the lowest glowing bulbs. So the lowest glowing bulbs are there in this row. So I will choose this row and I will toggle this. So I will switch, the switch was off, I will toggle it, I will switch on. So now I have 2 bulbs. Now I will select that row which is having the lowest number of bulbs glowing. So now I have equal number of bulbs glowing. So I can choose any row, say I choose first, and I will toggle it, I will have 0. And the final answer would be the number of bulbs that are glowing in this particular array. So the total numbers are 0 plus 2 is 2. So 2 are the number of bulbs. Yes, we can toggle the same row twice. We have no issue. So in this problem, we can toggle this twice and we can achieve the original configuration uh, there. So let us try to code this problem. How we can code this problem efficiently? I hope the solution is clear. We will have an array maintained in which we will keep the number of bulbs glowing, and then we will apply a little bit of sorting. So you will get to understand the solution once I start coding. So the input format is two, and I will be given two configurations. So into say test cases, I will have test cases. So for each test case, I have to do something. So now I will think about test case. So I will get an M, N, and say I will get a K. So I will get number of rows, columns, and number of attempts that I will be having. So now I will have a vector of integers original, or I will say bulbs lit, and there are m rows with, and initially everything is 0. So now this statement basically created an array of m size with all elements set to 0. Now I will start reading the configuration, or I can say the matrix for I should not take it I because I have already used for row. I will take a I will have a I have to make a matrix. It is given that I cannot have a matrix greater than 50-50. So let us have a character matrix. Character matrix say 55-50. It's always better have a matrix uh, greater than this given size. So the size here mentioned is that n and m cannot exceed 50. So I have taken 55-55. So C in a matrix R P if matrix RC is equal to a star. It means the bulb in that particular row is lit. I will simply plus plus. I will bulbs lit in the particular row. And now at this point, I have all the bulbs lit up. So bulb lit contain all the bulbs corresponding to a row. I think this makes little sense. So now I have to pick that bulb which is having the lowest number of lit bulbs. So I have to sort it in descending order. Why? See what I am going to have. I will have something like this. If row 1 contains say 3 bulbs, row 2 contains say 5 lit bulbs, row 3 contains 1, and row 4 contains say 2. So I have to toggle these two rows. So I have to choose then first 1, 2, 3, 5. So if there are 3 attempts, I will try to toggle this, and then this, right? So I have to basically arrange these numbers in a descending order. So how I'm going to do it? Sort the vector in descending order. Now this will basically sort in ascending order. If I have to sort in descending order, I have to give a comparator, this time the comparator function. So we have an inbuilt function called less integers, which is going to toggle the means earlier it was being sorted in ascending order using less function. We are going to sort it in a descending order. You can read about less after the webinar. Now the bulbs have been sorted. Now I have k attempts. So while k is greater than 0, so basically what I have to check, if I have any attempt left, for any left attempt, toggle a possible row, right? So I will choose the first row. So I will choose the ith row, bulb lit. Now I have the number of bulbs lit in the ith row. After toggling, the number of bulbs that will be lit is n minus bulb lit. So this is after toggling. पहले 3 बल्ब थे मेरी रो के अंदर जो ऑन थे, और 2 बल्ब ऑफ थे. टॉगल कर दिया, 2 बल्ब ऑन रह जाएंगे, 3 ऑफ हो जाएंगे. सो आफ्टर टॉगलिंग दिस, राइट, ग्रेट. एक अटेम्प्ट यूज हो चुका है, वन अटेम्प्ट हैज बीन कंज्यूम, द रो हैज बीन टेकन. We will see, Akhil, how one time sorting, that is why we have joined coding blocks. So we'll see that, no issue. So while k is greater than 0, now one thing I would recommend you people, what I have observed in many students, that they never check for the indices. I cannot say if my number of rows are 3, if my number of rows are 3 and k is say 300, I have to use 300 attempts on 3 rows. So there would be a point when I am going to, there would be a point, this index would be 4, 5, 299, 298 and so on, right? So I should always make sure that this index is always correct, is always a valid index. So while k is greater than 0, and what, and index should be less than number of rows, and one more at corner case is there. Say I have achieved this state, say for, now if I try to toggle, and I am on this particular, my k is on this particular row, so shall I toggle this or not? If I toggle this, the number of glowing bulbs will reduce. So the right answer is, if I have to toggle, means there is no other option, I should toggle this row rather than this one. So if I don't have any, if I cannot have a better answer by toggling, I will stop toggling the rows, right? So, and number of bulbs remaining should be greater than already this. You just try to think it later on, you will get why I have written this statement. This requires a little bit of thinking. Now at this point, either I have now at this point I have achieved the possible best. So if my k is not 0, if k is not 0, this means I have still attempts left, right? So now attempts are left. So which is the best possible choice at this particular condition to toggle? If my k is even, then it means toggling will nullify, so I don't have to take it into consideration. But if n is odd, it means I have to at least toggle one row mandatorily. So I will toggle that row which is having the lowest number of bulbs lit. Am I correct? So uh, I have to find the minimum element among the rows. The minimum number of, I want to find the row which is having the lowest number of lit bulbs. So this will give me the position of the lowest element corresponding to the means this will give me the position of the element that is the lowest in the vector. So position, the pointer to such a element, that is the iterator to such an element. So iterator to a vector can be, so I want something like this. So I don't know the data type of it is an iterator to a vector. So its iterator is basically vector of int का iterator. So an iterator to vector of int. In C++11, I can save myself by writing all this stuff by using the keyword called auto it. This can be used only during initialization. This auto keyword automatically infers the meaning of the RHS, uh, meaning of RHS. So these both are equivalent. So I now it points to the lowest element in the vector, and basically I will toggle it. So if k is not, so now so now the state is something like this. So three bulbs, say five bulbs, say two bulbs. So my iterator is pointing to two. Now I will toggle if it is if it is odd. So if k is 1, I will toggle it. If it is k is 2, I will toggle it twice and it will achieve the original state. So if I toggle a bottle twice, so the bottle is the same position. That is the same here also. So it if k is not equal to 0 and k is odd, only then I am going to do this. A mod going update this position value at value at that position is nothing but n minus value at that position. Hope this is clear. It is a pointer, so value at that pointer is nothing but n minus value at that pointer. So initially if it was true, if initially if 2 and n is say 5, n is say 5, what I am going to do, 5 minus 2 is 3. Now 3 bulbs are lit, right? Initially it was 2, 5 minus 2, value at that location, this location is updated to 3. This is the logical way I'm telling. And once this is done, now I just have to return the sum of all the bulbs lit. So I will simply return sum. So accumulate the whole vector. Okay, is it clear? I cannot return, sorry. We are dealing with I will recommend not using Endel and use this because Endel makes see out scene really really slow. And I hope this here you can read about accumulate, and if you don't get this, we can study in the next class. So I will run it. So it successfully compiles without any compilation error, and now I will try it on this problem. The expected output is 4 2. And yes, we are getting 4-2. So I hope this question is clear to everyone, and we will try to submit it. And we will try to submit it on the Pause website. It says compilation error because say so. So yes, it has successfully compiled, and I hope the solution is absolutely correct. We'll send you the codes because I have updated the link, so I don't have the code right now. I will send you by tomorrow noon, so don't worry about the codes. You will get it in a very organized way. And yes, bingo, we have solved this problem in 0 seconds just by using STL. So no sorting function. No sorting functions written by me, no finding the sum of an array, all by using STL. I think this is one of the best question that gives you a deep insight to the STL. I want to discuss one more problem with you, but because of shortage of time, I'm not discussing it with you. I hope this webinar has been beneficial to you. Please provide your feedbacks. I will post the link for feedback on Slack as well. So thank you so much for being with us. Very happy Dashera, and see you in the next class. Okay, thank you so much. So Pratik Bhaiya, I want to say something. Thank you so much, guys.
Was I hope you all liked today's webinar. So to share it, like it, and all those who have joined the course, I will see you in the next class very soon on 5th of October. And there is an assignment for you guys which I have already shared on Hacker Blocks for the first class. I will add more questions to it as well. The link is cb.lk slash contest slash CWC1. This is the assignment. You have to try questions. Apart from it, we will share the notes on the Slack. All right. Thank you guys. Good night. Take care. We will see you soon. And please be active on Slack. We are there to help you out and teach you guys new stuff, exciting stuff. So today's class, I would rate today's level to be easy. The next class would be more difficult with challenging questions, right? This was just the revision class. Now the actual bootcamp will start from the next class. All right. Yeah. शुभ रात्रि. धन्यवाद. मिलते हैं आपको 5 तारीख को, right? Bye bye. Links will be provided, don't worry.